That was going on, so I went back to graduate school and studied aviation safety and accident investigation at University of Southern California. I have all the ratings required. I have airline transport pilot rating, which is required to fly for the airlines in the United States. I'm also a flight instructor, and I have over 30,000 hours now of flight time. Somebody told me that equated to about 7 years in an airplane. So that's, by any measure, I think that's a lot. Some other fun things, I fly drones. I have a FAA commercial drone operator certificate. 3 years ago, I got my Seaplane license. So I have some experience in float planes, and I'll present a little bit about that in a little bit here. What else we got? I also do a podcast that if anybody's interested in podcasting, it's about music. I can talk about that offline a little bit later. And I also play trumpet. So anybody doing music here?
Me.
Okay, very good. Sound engineering, very good.
Yeah.
I'm going to make a huge assumption, and I'm going to assume that everyone in this room has at some point taken an airplane flight. If anybody has not ever been on an airplane, can you raise your hand for me? No. Okay. So everybody has been on an airplane. So where do pilots come from? Pilots are everywhere, and they come from all walks of life, but they have an interest in aviation. So we're going to talk a little bit about how training has been done in the past and what EON Reality can do for training going forward. So a couple of fun facts. So there's my flight training I did in my seaplane in Anchorage, Alaska 3 years ago. That's my instructor on the left. She was 84 years old at the time. She and her son run the flight school, and they do a terrific business up there, training pilots from zero or people like me that just want to learn how to fly a seaplane. On the right side, in my airline job, I get to fly with a lot of really interesting people. Some of you might recognize the musician Stevie Wonder, who was on one of my flights. So I fly a lot of high-profile people from time to time, and it's fun to meet some of these people. Let's see. So we'll move forward. Before I start with this part, I want to mention that I'm extremely honored to be here, and when I was here yesterday, I learned so much more about EON Reality than I thought I already knew. 3 things that I learned from yesterday. First was that all this learning has to start for young children at age 4. So going forward, we're trying to figure out how we can get this into the hands of children. The second thing was talking about children carrying 15 kilograms of books on their back, going back and forth to school all day and not using them. At the airline, I had about 15 kilograms of charts, manuals, performance manuals, regulations, and maintenance manuals that I would have to carry on a daily basis that I would rarely even open. Today, it's all done from a tablet. So that's how we've come in the last 10 years. And The third thing that I learned yesterday was that we have to bring the future to the present, because the present is our current future. So we have to take what we know can be done and make it happen today. And I'm going to show you a few things that we can do with EON Reality. So the first thing we're going to show is turbofan engine fire protection. Occasionally something can go wrong with the engine. It can catch fire or give a fire warning to the pilot. So we're going to play this video for a moment. I want you to watch this one.
A turbofan thus can be thought of as a turbojet being used to drive a ducted fan, with both of these contributing to the thrust. When an engine fire occurs, the temperature in the core section increases. The rise in temperature changes the resistance of the detector.
So we can show a 3D model of the engine.
The engine fire computer
And we can have a
constantly
portal
monitors
that
the
will show
resistance value.
the system on the engine that
This
detects
triggers
the
the fire computer to give a fire warning in the cockpit. The fire computer unlocks the left engine fire switch. Now the switch can be pulled out. Using the switch sends multiple commands to close all the engine systems. Fuel supply to the engine is stopped by closing the engine spar valve and the fuel valves in the hydromechanical unit. The bleed air pressure regulating valve is closed to stop the engine bleed system. Hydraulic supply to the pump is stopped by closing a shutoff valve, and the hydraulic pump is depressurized to stop the output supply. The breakers of the integrated drive generator and the backup generator are tripped. By pulling the switch, the engine is starved of all possible sources that might have caused the fire.
So that's a way of showing a 3D model of the engine and take a portal and show the procedure of what a pilot would do to put out a fire should occur. So a fire in any situation, whether it's an engine or anything, you need to starve it of the energy and the source of the fire. So in this case, we shut off the fuel, the hydraulics, the pneumatics, and the electrics. Then the fire is not fed any longer. If the fire still exists, there's a fire extinguishing system that can be employed in the engine to put out the fire.
And I just want to ask you, so for that, how would you look at that now? Is it primarily video or like a book or like how?
Oh, it's been a manual. So you read the manual and it says, this is how the system works. You pull this handle and this action occurs. This is the next step and this action occurs. And with this way of learning, it takes you through step by step. It highlights the system that we're talking about so that you don't confuse the electrical system with the hydraulic system with the fuel system. It's clearly depicted. And in the 3D model, you can clearly call that out.
Play the next one.
So next slide.
Yes.
Oh, a question already.
Is that actually directed towards the people flying the plane, or is it directed towards the people who are the engineers or the future engineers like that?
This would be directed toward the flight crew. So that's the pilots. Because if you're flying the airplane and you get an alert that there's a fire in the engine, you go through these steps while you're flying the airplane to put out the fire. So there's a different set of checks and inspections that the engineers would do on the ground for maintenance to make sure that all of these things will happen when you pull that fire switch to stop the fire. So there's a lot of testing. That's a very good question. Thank you for asking that.
Can I play the next one?
So the next one, okay, so this is digging a little bit more into pilot training. Typically when you train for a new aircraft, a different aircraft, a new seat on an aircraft, a new job, it's about a 30-day school process to go through all the training. Typically it's 2 weeks of training in the classroom and 2 weeks of training in the simulator. In the classroom, you sit in an environment like this, and the instructor points at things and says, this is this, this is this. And then we have something called a cockpit procedure trainer, cockpit mock-up. It looks like a cockpit, you sit in it, but it's paper panels that are arranged somewhat in the order that the cockpit would be laid out. The problem with this is that the training centers have to have these for each kind of airplane that they fly. It's 727, 737, an Airbus, a regional jet, whatever it is, you have to have these devices to train the pilots. So you might only have 3 or 4 of these available at the training center that the airline operates. I'm going to show you a different way of doing this and see if you can tell what the differences might be. Spatial media. So here we have shown a model with an
I'm a Boeing 777 captain. In this presentation, we're going to go through the basic layout of the Boeing 777 cockpit.
So here we can use a spatial meeting.
We'll go through the
Actual airline
display
flight
here,
instructor
known as the moon control panel,
sitting in the right seat,
and that includes
taking you through
the altitude select window,
the diagram of the
escape
airplane.
window,
So instead
landing
of
aircraft
you
select
and the
window,
instructor sitting in
and the
the
airspeed
cockpit
window.
mock-up,
These are
both
the
can be
controls
the
to
instructor
guide the
may not
airplane
necessarily be
or
at the
control
training
the
center. He
pilot's
might be
functions.
somewhere else in the world.
We'll have the forward
You might be
panel,
somewhere else in the world doing this
including
prior
the
to coming to the training center for
attitude
your
director
training.
indicator,
This will save the
with a
airline
multi-function
time
display.
and,
In
of
this
course,
case,
dollars
it's
in the training
showing
process.
the air conditioning, temperature, and air
So
control
this way,
systems and
you
layout,
save
and
4
air
of those
temperatures,
cockpit
and all the
mock-ups
cabin
pilots
zones and the
have
cargo
an
areas.
unlimited number
Next to the standby
of these
instruments,
scenarios
standby
where you have
attitude
spatial
indicator,
meetings.
standby airspeed, and standby
You can do
altimeter.
it on your phone.
In the center, we have the
VR goggles.
upper ICAS display, which shows
You can
some of the
interact in real
engine
time with your instructor
control
sitting.
instruments, and also shows the ICAS alerting message system, and the current temperature and fuel load.
Okay, that's
Next to that, we have the landing gear selector lever.
Next one is Metaverse Builder, Runway.
okay. So now we're going to Metaverse Builder, and we're going to learn about runway safety training. Runway safety training is a very important component of airline and airport operations. There have been a number of high-profile incidents and accidents lately of aircraft landing at the wrong airport, landing at the taxiway instead of the runway, taking off when they shouldn't be taking off, crossing a runway when they shouldn't be crossing the runway. So let's take a look at this, and there will be a little quiz at the end. So please pay attention.
Runway Safety Awareness training in augmented reality. There is a focus on what the U.S. FAA terms correct surface operation. This means landing or taking off on the assigned runway and not crossing a runway unless authorized. Runways are identified by white markings and taxiways are identified by yellow markings. At night, runways are identified using white lights, taxiways are identified with blue lights, and taxi routes are identified with green lights. Here is an example of a typical airport layout in augmented reality.
Notice the knowledge portals that we can bring up to bring up more detail.
Hello. So today we're going to be taking a detailed look at the runway markings that you will find at an airport. So let's get straight into it and start by taking a closer look at a runway. Regardless, let's take a look at some of the components that you should find on most runways. First of all, a runway will have a center line, a long dashed white line which runs along the length of the runway. This of course identifies the center of the runway and also aids pilots with lining up correctly. Next you have the numbers. Now runways are numbered depending on the direction they face on the compass. For example, if you were stood at the end of this runway, you would be facing east, 090 degrees. You drop the final number and you get the runway number.
The runway thresholds are markings across the runway that denote the beginning and end of the designated space for landing and takeoff.
This lesson will explain the markings on the runway. The markings are intended as a safe way for pilots to direct their attention while landing an aircraft at an airport.
So here we can have a quiz at the end. So we're asking what part of the runway this is. This is called the threshold. We've correctly identified the threshold. So here's my quiz for you right now. What color are runway markings and runway lights? White. What color are taxiway markings on the ground? Yellow. Blue is right because that's the color of the lights are used at night. And there's one more, green lights. What were green lights? Taxiway routes on the taxiway. So we have a lot of markings on the runway, lights, to help pilots take off and land and taxi around airports in the correct manner. And this is an excellent way to reinforce that at piloting of all levels, even somebody just learning to fly from the beginning, because they have to know this as well.
I just wanted to ask your opinion on the AR, because we did do that in the middle of the street with a kind of giant model, if that's perspective is helpful.
Yeah, so you can scale this up to even to a 1-to-1 scale. So you could walk through it, you could stand on the runway, you could stand on the taxiway, you could walk the length of the runway. It's something you can't really do at an airport because there's too many airplanes there. But here you could do it very safely.
All right, bird strikes.
Okay, so next I want to show you this Metaverse Builder. So we're going to talk about the bird strike. So we all remember the miracle on the Hudson airplane, Captain Sully. Both engines failed after they flew through a flock of birds, and he was able to land the airplane with no power in the Hudson River in New York, and everyone was safe. But in our training, we don't specifically train for bird ingestion. We train for something we call severe damage. It could be from a bird, it could be from another object, it could be from a tool a mechanic left in the engine. It could be from a number of things. But we're going to use the bird strike scenario because everybody is familiar with that. What this is going to show is some more information about the jet engine, and then it's going to show a cockpit simulator event where they practice what would happen if they did run into birds. So let's run this video. So here we have a 3D model of an aircraft that's pretty close to 1-to-1 scale, pretty large. You could walk all around this aircraft. And again, we've inserted some knowledge portals to add some more information. Because the focus from EON Reality is on knowledge. The more knowledge we can insert into a presentation, the better it's going to be retained by the student. So here's some information about what happens to an engine with a bird strike. You can see the middle photo there, some fan blades missing as a result of the damage.
787 to 9, 206 feet, 63 meters long, can fly 7,635 nautical miles.
So a little bit about aircraft engine design. We can explode the engine, look at an exploded view, or we can simply open it up and take a look inside.
In this video, we will explain the technology behind the jet engine in a logical, step-by-step manner.
Again, we have the knowledge portals, and here's the video of the bird strike scenario in the simulator.
Okay, that didn't sound very good. On the right. Okay, so statement function, please, Elton.
So, loss of N1, AGT, then to decrease.
And the portal on the right, you can see more information about the severe damage procedure the pilots will follow.
To restart the engines. So if you can start the APU, please.
starting APU and I will declare Mayday.
Yes, please.
Dublin, Mayday, 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 Mayday 360. Engine.
Everything happens pretty quickly when you run into a flock of birds, and you have to react quickly, but in a methodical manner.
I'll be turning right and will request full emergency.
More information about bird strikes in the knowledge portal up there.
Yeah. Flaps 40, please. Flaps 30, flaps 40. There we go.
And here the pilots are coming in for their safe emergency return to the airport.
Race.
Race, race, race. Spin rigs up.
Max, manual braking.
Put our nuts.
So that's a little bit of what can happen when you're out there flying. Hopefully not very often. When it does, you usually read about it, and you usually read about it because the pilots were well trained and they landed the aircraft safely. So that's a way of showing the metaverse builder. And so one more we're going to show is the fun thing for me, the float plane training. So float planes are different from land-based airplanes because they're on a float. There's several kinds of aircraft floats. There's floats we call straight floats that have nothing below them, so they land only on water. We have amphibious floats, such as these, that are floats that have wheels, so you can land on airports or on the water. There's seaplanes that use the hull as the landing surface, and amphibians, which use the bottom of the aircraft to land on the water, but also have wheels that can land on the airport. So here's some knowledge portals about flying float planes. DHC-2 Beaver, made in Canada, the most popular one. These are in extensive use in Canada and in Alaska in the United States. Here's another one. This is the Beechcraft Model 18 twin-engine airplane on a float, and we can explode the model of the Beech 18, and again, 1-to-1 scale. So you could walk around this, you could look under the wing, you could look at the engine, and again, some knowledge portals. Going to show one here about what it's like to fly one of these.
So this past October, I had the opportunity to spend a weekend at Sky Harbor with Lake Country Air. This particular opportunity was to get a multi-engine seaplane rating in a Beech 18. I guess if anything surprised me about the way it flew, it was how easily the twin Beech came off the water. Very deliberate, very positive movement as it comes off the water. And my only comparison really is a Super Cub on amphibs that I fly quite a bit when I get to see the seaplane flying. And the Beech was, I would say, much more stable, much easier to fly, quite frankly, on and off the water than a Super Cub on amphibs.
So that's some seaplane operations.
That's the last one. I think that's the last
And
one. Oh, this says TBM.
oh yes, okay. So the next we're going to talk about MRO, maintenance, repair and overhaul, aviation. This is for the technicians. Somebody was asking about technicians.
Regular maintenance needs to be performed on this aircraft by certified aviation technicians to keep it in running order. Some of these items include annual inspection, oil changes, and service bulletin compliance or airworthiness directive compliance.
So again, there can be quizzes embedded here. And this shows what we call
TBM 930. It has a Pratt & Whitney turboprop engine with 850 horsepower, given as a service ceiling of 31,000 feet of over 1,700 nautical miles.
EON
In 2016,
even,
the company
hot air
launched the
ballooning,
improved
population
TBM 930 turboprop
aviation
aircraft.
as well.
That same year, the 800th TBM came off the assembly line. Dawn Air's aviation activity
X-ray view
includes
of
the
the
design.
aircraft or an exploded view of the aircraft.
This is a TBM 930 aircraft. It is used
And we're
as a
looking
leader in
inside
business
the
aviation.
virtual hangar as well, so we can modify anything, move anything around, whatever we'd like to do.
That's the last one.
So I have one more presentation for you. This is on the airport operations. So we all go through the airport. You go through security, you go through passport control, you make your way to your gate, and you get on your aircraft. But what about when they design a new airport, or they want to design a new passenger facility? We've got a relatively new airport here in Istanbul. So that had to be designed and thought through, where the passengers are going to flow, where the airport workers are going to flow, where the baggage is going to flow. In this case, we had access to a
787
airport.
is an unbelievable
So we
airplane.
get
Not
a
only for
close-up view
customers,
of the
but
airport
for the employees that work
operations.
the aircraft. You know,
And we can take a 3D model
sort
of
the
the
lighter
aircraft.
materials are more fuel efficient.
And,
where
pretty
it
fun
gives you
when we
different kinds of
compose that
shades. Right now, this is the lightest one, and as you press the button, and the passenger on
There's ramp safety, there's security, there's a number of things that need to be done around the airport beyond just the passenger terminal. Here's where we took the small aircraft model and we put it next to the real one. Sometimes it might be hard to tell the difference. Here's an airline with an exploded and an X-ray view. And there's the actual airplane right behind it. And again with some knowledge portals.
Engine still remains the most hazardous zone on the aircraft.
And here's the part about the engine, and here's the part I wanted to show. So here's a 3D model of the airport design in augmented reality. So you can see where the passengers would sit, you could see where the gate agents would be, you could see people queuing up to board the aircraft. So when you're designing an airport, you can lay this all out, figure out how many passengers you can put through, where they're going to be, how they're going to flow, and you can train your airport personnel in how to handle passengers. Passengers, after all, make the airlines run.
Thank you. I think that was super different. I was going to say, now for something completely different. So, really appreciate your giving us kind of concrete examples in the area of aviation. And so with that, I'd like to see if there's any questions on creating these. Yes. Might need a mic. Is there questions there? Questions? Okay. Anybody have any questions on creating these or anything about aviation? It's so quiet over there. Okay.
So we have the virtual reality, augmented reality, metaverse builder, all used in the aviation context. So thank you very much.
All right, thank you. Thanks for doing that.